All right, everyone. We're going to discuss the Excel AI initiative here. This is really supposed to be a whole bunch of short vignettes, 3 to 5 minutes ideally, where we cover content, allow for a series that you can go to on the topics that are your interest. We'll highlight not only the benefits for education, industrial, commercial applications, but also defense. So next, we're going to build off our knowledge of the AI agents, as well as Ender's Game, where you saw some really cool UAS applications, and we're going to discuss for a company called Heron Systems, now a Shield AI company. And so DARPA Dogfight Trials held this competition against the top five, narrowed down to where you have these two jets opposite directions start in a simulation and use their AI to try to merge and shoot each other through a regular gun scenario. So what's cool about this is you have like perfect information from the simulation being loaded to the opposing aircraft, but by doing that, you're able to develop machine learning models through AI agents, millions of games over time to come up with best agent for a certain application. And that's what Heron System has done. And just a little spoiler, they actually won, even beat Lockheed Martin, which is really cool. And then they actually got to go against a real F-16 pilot at the end. So we'll showcase one of the scenarios against Aurora, how the simulation looks, as well as the Lockheed example, and then one of the examples against the human pilot. Start my screen share sound, and we'll begin.
Number one.
Very much so. You have to be concerned if you're on the Heron team that your agent may have overfit to that particular tactic. I remember fighting BFM against a pilot that would tend to do a very aggressive gunshot, and where most pilots would
So you see this
reposition, come off of
merge,
that attack and change tactics, this individual would just keep on.
and just a little for awareness to get your bearings. This is kind of the life scale, so it's a probably bullets that hit a target and where it hits the aircraft. You'll see the heading, vector headings, the speed, all the information that's being used to calculate what these AI agents or aircraft should do, and that give you a little context as we go into the next example.
Trucking. And if it caught you by surprise, it would usually result in you dying and losing that fight. But if you were able to react to it, if you're able to learn and adapt, then now you could capitalize on that BFM error when his aircraft overshot. And I think that's what we're seeing here is if you're that Heron Systems team, as long as your tactic is working, it's great. But we're going to see if the other teams are able to adapt to that and overcome with other skills in this BFM arena.
Yeah, certainly Heron has proved that they're lethal coming into the
All right, so you saw that the life went down to 0. We'll go to the next example. All right, so we got Lockheed.
the
They
first
start the merge.
and Lockheed draws first blood for their team. 4-1, 4 quick kills by Heron here in the Alpha Dogfight Trials. This is the finals. We've been training a year for this, or the teams have been training a year for this, and very exciting matchup between our number 1 and number 2 teams.
That's right. And we've talked about how these very aggressive
So you see
game
a life
plans,
go almost at
they
20%.
can work very well when you're able to get the entire kill on that leaf. But if you're not, then you may have committed something of a BFM error. You may have given that other aircraft a potential advantage to exploit. And if they're able to do so, that whole fight could switch over to the other team's advantage. And you're seeing Lockheed doing a really good job of making sure that they're extracting their pound of flesh in those initial merges, and then they're maneuvering aggressively and trying to get their nose on very quickly to get some more frames on that Heron
Another
Systems
more
team.
or less neutral merge there. This fight, the first couple of fights probably didn't, go past maybe 10 seconds. This one's almost a minute now. Some turning, both aircraft not with a lot of health left.
All right, and then you see the win. So data for training these models as you have agents that are getting better over time could be at NGTS, next generation threat systems, AFSIM, but all these models that produce some basic data for flying these aircraft could be used to train the models. Now, that gets you so far. Eventually, you need to get real world data. So thermal imaging sensors, radar sensors, all these different things that can potentially impact the model performance, and actually aircraft sensors is critical in this case. So the challenge is really, really big, especially just for one-on-one aircraft, alone 2-on-2, 4-on-4, or more highly diverse use cases. So we'll go into the case now where we actually go through an actual pilot.
And once again, if you're joining us, you look in the lower right-hand corner, you can see sort of a stoplight, red, yellow, green, and that's when we know that the fight's getting ready to kick off. That's Banger in the VR setup really driving that engagement. Neutral conditions, about 2,500 feet separation. What's the airspeed we looking at there?
400 knots. So they're going pretty quickly here. We'll see as Heron does that kind of up and away pitch, looking for an opportunity to get that nose around. Banger digging low into the inside to try to stay outside of that nose
You can
cone.
see the simulation. Looking around, you can
Gets
actually
there,
tell where
coming
you're
through the
going.
merge, surviving that
Banger
merge
nearly
barely.
got killed on the
Let's see if
first
he can
merge,
saddle
but
up.
you'll see he'll try to get away.
Aggressive over the top maneuver. Looks like he's got maybe perhaps a positional advantage now.
It's going to be challenging though, that range, if it opens up out there, that 5, 6, 7,000 feet, but he survives. Heron going to use any of that range available to try to get their nose on and be able to get that gunshot that they are so very good at.
Close down to the deck, guns almost looking like aggressive nose move up, able to avoid the gun shot there by Heron.
That's right. I think what you're seeing here is a shift in tactics from Banger. I think you're seeing him look to see if he can maneuver to get this adversary down to the floor. Can he scrape them off on that 1,000-foot hard deck?
And we certainly saw some of that in the semifinals. A couple of teams falling victim to the
inside, and
have Heron.
You think about it, between the two airplanes, where
Banger really wrapping it up. 9.
And now he's had a chance to play the sim. He's actually trying different strategies in order to survive a little longer.
From, Heron, who's been pretty lethal with the gun, looking to find some way to get behind Heron without getting shot getting there.
And getting right down to the floor. Banger down at 1,300 feet. He's going to really make Heron prove that they can do this gunshot at the floor. One of the most difficult things you can do in airborne execution in an F-16. We'll see if the AI is able to hack it.
I get it.
This tactic seems to be working for Banger. If you take a look at it, Heron is really having a hard time getting that gun nose on and getting damage against Banger's aircraft down there this low to the ground.
So pretty good closure right now. High aspect shot there. Banger going to the vertical.
Just amazing. This is really aggressive maneuvering. If you look at the G meters in real world, we're talking 9 Gs, really physically demanding, 500 knots. You're talking about flying around in the air greater than 500 miles an hour and trying to do these very fine motor skill controls against another aircraft. Absolutely impressive work here, both out of Banger and out of our Heron agent.
So a little caveat, the information you're using for training will get better over time, and is pushing the boundaries of like the human body. So 9 Gs is pretty intense. So as you get into teaming applications for unmanned systems, you can actually pull higher Gs, maybe make aircraft to higher tolerances. What's cool here is you can imagine if you had like a super aggressive, maybe not so aggressive, 2 models to play with, combined with the human capability. You have 3 capabilities, and you might be able to take a 25-year-old pilot and give him the skills of an ace pilot. So imagine something like Top Gun Maverick, where you can do these capabilities completely with unmanned systems. So food for thought as you think about AI agents for not only games such as just a simulation like this, but also for defense. Thank you.